Hi, I'm Trustin from Databricks, and in this session, I'm going to talk about writing a Java library with better experience. This talk is basically made of three parts. The first part, I'm going to talk about core principles, and the second part will be mostly Java-specific tips and tricks, although it's applicable to other languages. And lastly, I'm going to talk about how to nurture the community around your library or framework. This is really important. So my experience came from these projects, Netty project and Armeria project. Netty project is pretty well known, and the Armeria project is a relatively new project, but they have bought Twitter accounts and GitHub repositories. Please feel free to start them and follow them. So let me talk about core principles first. So the first principle is to be in user's shoes. This is basically about continuously thinking about what will users' code look like. So to design a new API for your library, you have to make sure to make sure not to implement quickly. Implement first. You have to forget about how you're going to implement it, but you just open a notepad and start typing like the API is already there and it's already implemented. So that make sure that your user's code will look better instead of your implementation details are better. So based on that, once you're done with initial phase of doing this, you can add in more complex cases, use cases increasingly a little bit by a little bit, and continuously you keep refining those prototyped API. And once you're comfortable, you are sure that you reached a certain level of confidence, then you can continue on to implementing the implementation detail part. But in this phase, it is really important to keep in mind that this is not a sprint, but a journey. It's going to take a long time to get it done. So you don't really need to hurry up, but just focus on making things right in the beginning. And the second principle I'm going to talk about is consistency. So when you deal with some other libraries you're using, you often end up thinking like, why is this like A and why is that like B or something like that. This means the library has some kind of consistency problem. And you don't really want that kind of problem in your library for sure. But sometimes you are not really sure which one is a better option, even if you want to make it consistent. For example, you might want to make your builder accept long. Sometimes you might think it's probably better accepting duration. So in that case, you will want to check what others did for their libraries. For example, for Java, there's JDK. For Kotlin, there's Kotlin SDK. And also there are many other popular libraries like Guava, Spring, and so on. So check what others do and get inspired by them. But do not follow them blindly because they might have made some kind of mistakes already. So make sure to think critically and adopt some good ideas from their API and try to be consistent. And you also need to think about cognitive load and learning curve of your library. So in some libraries do the opposite of this. They provide so many little different concepts at one shot, and they require the users to learn about them first. And once all those concepts are understood, it is easy to work with. But it never happens in reality. You have to start with a small number of concepts first, and then build more complex stuff on top of them. So try to design your API around the learning strategy of your library. So to do that, you often use some familiar constructs like builders, factories, decorators, and strategies like this kind of design patterns. And because functional programming is now pretty popular and uh, being used by many people to some extent, you will also think about, you'll also have to think about functional composition. But please keep in mind that you really should not expose too much at once, like exposing 10 overloaded builder methods in a single builder. It's going to overload your user's cognitive load significantly. And another thing to consider is user experience. So in many cases, when you write a library, people often encounter the situation you have to trade off between user experience and internal complexity. In this case, you almost always choose user experience, because otherwise you're going to go into some vicious cycle. And if you choose good user experience, then it is more likely that you enter the virtuous cycle. So let's say you introduced some poor user experience to your library, then it will confuse your users. That means many users are going to file support tickets. Hey, this looks like a bug, things like that. And that means poor experience to your users. And because the developer has to deal with these tickets and tell them this is not how it works, and hey, this should be done this way, things like that. So it takes more time for developers to deal with these kind of trivial tickets significantly. And this means a user will also be unhappy about this, and they will not give much feedback about how they feel about the project. And because the developer will have to deal with many trivial tickets, it will often take up quite a bit of time and leaves much less time for writing actual code, making developer feel bad. So they try, because they are in short of time for coding, they will not spend enough time for fixing the problem properly. As a result, the fix will not be in its best form. As a result, that will lead to more confused users and so on. So it's a bad vicious cycle. So to avoid that, you almost always have to choose better user experience over internet complexity. And ironically, API with good user experience often leads to better implementation, because better user experience often requires good practices like encapsulation and composition, which means more freedom at the implementation level and less complexity at implementation level. So far, we talked about core principles, and now I'm going to talk about Java-specific tips and tricks. So the first things first, I recommend using Java for writing libraries and frameworks instead of other languages like Kotlin or Scala, because using other languages means additional big runtime dependency. So if you write a Kotlin library or Scala library, it will pull in multi-megabytes of Kotlin SDK or Scala SDK library, which is pretty big, and people obviously do not want to pull those in unnecessarily. And because those languages try to implement something that's not available in Java language, it often generates some kind of synthetic classes and methods. And it often makes IDE's auto-completion a little bit dirty, increasing the cognitive load. And these languages provide pretty good interoperability with Java, but they do not. They sometimes do not provide good interoperability between other non-Java languages. So this might not be a good idea to. It might not be a good idea to write a library in non-Java language. So in my opinion, it's better keeping the core part of your library in Java and provide a language-specific layer on top of the core. For example, you could build your core in Java and then provide some Kotlin DSL or Scala DSL on top of that. And this also provides the chance of adding support for other languages, even more languages. And in the previous slide, I talked about people do not like having a big dependency. So it's important not to depend on another framework when you build your framework. If you depend on another framework, it means your users have to depend on two frameworks, which is not good. So what's important is to make sure the core dependencies are minimal and provide additional integration layer on top of that, so that people can choose different integration layers based on their preference. And obviously, some people just do not want any integration. They just want to pull the core in, and that's all. So it gives more choices to your users. And sometimes you have some utilities classes you are interested to use, like Guava, Kotlin, FastUtil, JCUtils. There are many libraries you want to use in your library or framework. But pulling those dependencies directly might cause some kind of version conflicts. So I recommend shading them or shadowing them using some build plugins. But because shading all these libraries will increase the size of the jar file you're distributing, I recommend using a tool like ProGuard to trim unused classes. So for example, Armeria was like 30 megabytes in total after shading, but after trimming unused classes, the size went down to 6 megabytes. But this has some kind of legal implications because it basically redistributes the bytecode. So you're not supposed to do this for LGPL libraries, for example. So be aware of licenses. And although Java provides a construct for optional type, Java lang optional, I recommend using @nullable annotation instead and just return null. It's mainly because a language has its own null handling mechanism. So, for example, Scala has option type and Kotlin has nullable types and Java has optional. So in this case, we just return a null when the return value is null, so that the caller can wrap the result. For example, in Java, a user can just call optional nullable, and Scala users can call option. And it's also good for performance because escape analysis for optional object does not always work. It all depends on how inlining is done by JVM. But the annotation can be pretty verbose. For example, a user will have to specify @non-null annotation for non-null types and specify nullable for nullable types. But in reality, most return types and fields are non-null. So we usually define this kind of annotation so that we don't really have to specify non-null annotation at all. So we just annotate annotate with nullable only when the field is nullable. Otherwise, everything is non-null. And in reality, in the market, there are many nullable annotation libraries. You might think it a little bit awkward, but it's mainly because there are not real standards for this. So there is JSR 305 based JavaX annotations. This is the most popular one, but this is not actually standard and it's not compatible with Java modules. So you're gonna have to think about this when you adopt it. And JetBrains also provides its own annotations. It has good IDE support because JetBrains builds IntelliJ IDEA, and it has interesting contract annotation, which is useful for defining some contract, literally. And there's some effort to replace JSR 305, but it's in the very early stage. But you could keep an eye on it. It might become very useful in the future. And there's also Checker framework, which is more than just annotations. It also provides some kind of static analysis tool. So you might want to check that out too. And another tip I want to give is to validate early. So there are two stack traces in this slide. The first thing is the exception is shown when shown by server builder.idle timeout. And the second one shows an exception in a socket called by build. And the exception messages are also different. The first one tells idle timeout is null, and the second one does not give any information. I think the first one is obviously better. It's because it has way less cognitive load. So what's important is to give an exception as soon as a bad value is given. So do not validate builder properties at build, but just validate when it is set. So in the previous slide, the first one raised an exception when setting the idle timeout property. But in the second exception, the exception was invoked. Exception was raised a little bit later after build method is called. So it's a little bit too late to tell the user that there's a problem. And also, you also need to provide a meaningful message. If you found a user specified null, then you have to tell what is null. And if a user gave a bad value, then what is bad value and what is good, what it is expecting, you have to tell them. Otherwise, a user will have to look into the source code of your library, which is kind of tedious. And speaking of exception messages, it has to be consistent for consistency. So for null pointer exception, I recommend just telling the parameter name or the variable name. And for illegal argument exception, you have to tell which parameter is not valid and what value it has and what is the format of the good value. So here are two examples. So idle timeout millis and file path. So we said we mentioned the name of the parameter and what value was specified, and then what value was actually expected. From this example, from this exception message, a user can figure out what bad value was given and why this is not working. So this is just an example, and your project might have different requirements from Armeria or Netty, so choose whatever works best for you. But the thing is, the messages should be consistent and meaningful. So here's an example from Armeria. So for port, we checked null by using require not null from JDK. And for HTTP2 max stream first connection, we used Guava's check argument method. And we used some consistent exception messages. And when you provide a way to construct an object, you have to use static factory method over constructors. It's pretty well known to some of the developers, but some still simply use constructors. But it's almost always good to use static factory method because you can name static factory methods, and you can also provide an access to builder, and you can return some optimized instance instead of the default instance because it's not constructor. So this is an example. So in this empty method, we returned a special empty singleton instance, which would not be possible when we were using constructor. And of is the same. We return different implementations depending on the number of actual endpoints. So this returns an optimized implementation, which is also impossible when we were using a constructor. And another a little bit controversial, debatable practice is to avoid inner classes. So some libraries prefer using inner classes for builder, for example, but usually IDEs like IntelliJ and Eclipse imports. When we import a builder class, it leaves builder only in the source code, except import statement. So eventually, the person who reads the code will have additional cognitive load to figure out what builder it is. And let's say what happens if we import another class .builder, then sometimes it becomes builder and sometimes it becomes other class .builder. It's not good for aesthetics either, and it's confusing. So because we always prefer better user experience over internal complexity, so I recommend not using inner classes. So in this case, for some class .builder, we could use some class builder instead without any dot. And I also would like to suggest not using Rumble or other code generators. It's often okay for generating internal classes, but public API requires a lot more human touch, like handcrafted Java. And also, to use these kind of code generators, you have to configure your IDEs properly, which adds another layer, another step to contribute, which is not good for attracting people. So here's an example of a handcrafted setter in action. So this is basically a simple setter that sends a single string into a field, but in Java we have a lot more than that. So we add in a hyperlink to the specification, and we explain what values are allowed and what values are not, and when this is used and when this is not used. So this is an example from Armeria again, and as you see, this provides pretty good amount of information to users, which would have not been possible if we were using simple code generator. And because when people start to rely on a certain library, they are not going to be happy when they see a breaking change. So we have to follow some semantic versioning. So it's a very big topic, so I'm going to just talk briefly about this. So it's made of 3 components: major version, minor version, and micro version. When you bump a major version, it means breaking change. And minor version, then you add a feature or you make a significant change internally. And micro version, you only do bug fixes. You can just replace a jar without recompilation, then everything should work. So it's actually pretty hard to follow semantic versioning strictly. So you're going to have to rely on tools, or you have to compromise a little bit, but you have to make sure to do your best to follow semantic versioning. And you have to keep your public API to minimum. So let's say you got contacted by one of your user, and he or she is asking if you can make some internal class public or protected, so he or she can access it because it provides some useful feature. And you have to think again because it can be opening a can of worms. So if try to hide all these implementation details using static factories and interfaces so that implementation details are hidden, because otherwise a user can access it and it will be way harder not making breaking changes. So to avoid the breaking changes, you have to hide almost all of them. And in the same sense, in your public API should be final in many cases, unless the API is meant to be extended. So you must always prefer composition over inheritance. So instead of inheritance, you can use function, consumer, predicate, things like that for composition. Because why? Because a user often forgets to call super or performs something totally unexpected. So to prevent users from doing that, you have to use functional interfaces and then do some composition instead of allowing inheritance. And sometimes a user will also come to you and tell like, hey, I want to extend this class or this method. Could you please remove final from it? It's just one keyword. Then you're not supposed to do that. You should not really do that because it's again opening a can of worms. And sometimes your library cannot always be stable because if you just added a new feature and it's too early to tell if it's stable or not. In that case, you could introduce some additional annotation that signifies how stable the API is. For example, beta, unstable API, kernel API, maturity level. There are so many options. So choose what works best for you. And however, it's probably not a good idea to add this annotation to every classes because there's no point of doing that in semantic version. And of course, because Java library is also just a piece of software. There are many engineering tips that applies in the same sense to libraries. So make sure to keep your code clean and write some good documentation and try to automate tedious stuff and prefer immutability and things like that. Now, this is the third part I'm going to talk about, the community growth. So you built a library, that means you need someone to use. But because it's young, so there are not many users, sometimes no users. It can be pretty depressing or sad, but If you just waited for a couple months, then it's too early to tell. It usually, for a library to become popular, it takes more than a few years. For example, Armeria required more than 3 years to get some real customers. So even if there are not many users at the moment, please do not give up. This is something like a marathon. So until there are actual users, you need to keep improving it by dog fooding and continuously working on it, because otherwise people will think the project is dead, or the project does not work anymore, or things like that. And of course, you have to keep your documentation is good enough, because otherwise they will think the project is abandoned as well. And once you have some customer or potential customer, you have to engage really actively, proactively. So set up some Slack channel or GitHub so that people can come to you and chat, and you could try to understand what they are saying, because not everyone is good at textual communication. And at the early stage of the project, every single visitor is very, very important. We are not a big project yet, so even a single customer will be really, really big for us. So try to engage proactively, try to create a new issue for them and summarize what they are saying. It's eventually going to be a good for yourself and the customer as well. And if they are happy enough, they will probably provide some additional feedback, or they sometimes even send a pull request by themselves if they are confident that this project is going to be pretty good. So this is one of the example. So Tobias and I were discussing about some new features and exchanging some feedback about that. And after the conversation, I was thanking him for providing some additional feedback. And he was a little bit confused, because he thinks he is actually the guy who needs to thank us. So thank you, overload. And let's say you have some visitor in your project. What are you supposed to do? So you don't really have to wait until they talk to you. You can just talk to them, keep asking questions proactively. Like, how did you find us? What features do you like about us? What is missing? What could be added or improved? And are you using it in your production or not? And what could help you decide? And eventually, if you have some good relationship with the visitor, you could also say like, are you interested in sending a pull request for us? And then he or she might accept the offer, which is cool. And of course, because it's working with people, usual soft skill helps a lot. You have to be thankful for whatever, and you have to assume good faith, even if the guy you're interacting with is saying something that doesn't sound good, but you can always find something great from them, like good feedback or whatever kind of feedback. And even if there's some bad conversation going on, you really should not take it personally, because it's about project, but not about yourself. And you sometimes need to agree to disagree when there are some debate and you have to make a decision. So you don't really have to feel bad about it. And because although it's all about development, but it's all about people as well. So consider using some humors or emojis and GIFs. So they are gonna make things way more smooth. And of course, you should not spend too much time on this. You have to also code. And if you are not comfortable with dealing with people, then you could just step away for a while to prevent any kind of burnout. And last but not least, you need a website. Now, some people might argue that readme.md file is enough, but it's not, because it does not provide any traffic analysis because it's hosted by GitHub. And GitHub provides only minimal traffic analysis. You have more detailed traffic analysis to get more information. And GitHub's website is not always mobile friendly, so readme.md is only visible after people scroll down quite a bit, which is not good. And that means not much room for elevator pitch. And it's not very beautiful either. So my recommendation is to find some site generator that works best for you. For Armeria, I used Gatsby, and it was pretty good. So this is an example. So previously we were using Sphinx for our website, and we switched to Gatsby to provide some nice landing page. And because we had a website, we were able to measure the difference between the left site and right site. So after this site to update, the number of users and sessions were increased quite a bit, and bounce rate also has decreased quite a bit, which is good. But without a website, you cannot measure this. So I strongly recommend building a website, even if it does not look as nice as this one. And if you have a website, you can keep your eyes on referral logs. Referral logs provides really quite a bit of information. Like, let's say somebody wrote about this project and then had a hyperlink to it, and then it will be recorded in the referral logs. I was able to use this information to contact the content authors. For example, on the left side, I contacted the guy who spoke in a conference about microservice frameworks, and I was able to get some feedback from him. And on the right side, I was able to find a project that uses Armeria. So I was able to contact him and tweet about the project, and get some interaction from that, which was pretty nice. And because every user can be tomorrow's developer in a library world, you have to spend your time for good onboarding experience, like how to build, how to set up IDE, coding conventions, what styles are preferred, things like that. So if you're interested in what a good developer guide looks like, please come to armeria.dev website to see one. And if you have more time, you could consider speaking in a conference, especially it's much less taxing in terms of travel because of the current situation. And you could also host some contributor events, either offline or virtual. And if you're not familiar with this, you could also try this with your colleagues at work first. And if you're interested about how we work, you could watch and learn from the projects I'm running. For example, Armeria project and Netty project. So if you're interested, please meet us at GitHub or armeria.dev website. And you can also scan this QR code to visit the website. And please consider starting us if you like it. Thank you.